Privileged passwords are powerful and risky when unmanaged. In this section, we'll look at how PAM vaults centralize secrets, control checkout and approval, rotate credentials automatically, and turn privileged access into something governed, monitored, and much harder to abuse. So far, you've built the foundation. IAM concepts, privileged accounts, least privilege, zero trust, and emergency access. You've also seen how those ideas map to PAM architecture, including vaults, connectors, policy engines, and integrations. Now we focus on password vaulting and credential rotation, before moving into sessions, workstations, SSH secrets, and governance. One privileged credential can open the door to servers, databases, network devices, applications, or cloud consoles. When those passwords live in spreadsheets, scripts, configuration files, or someone's memory, security loses control. They get shared, reused, forgotten, and rarely rotated properly. A password vault changes that model. Credentials are stored centrally, encrypted, and released only through policy. Access can require approval, be limited to the right time, and be fully logged. That supports least privilege, zero trust, and clear accountability for privileged activity. A password vault is not just a place to hide passwords. It is the control point for privileged access. Users, applications, and automation request credentials through an access portal. The policy engine decides whether the request is allowed, and approval workflows add human authorization when needed. Inside the encrypted vault, secrets are stored as managed objects, including passwords, keys, tokens, and certificates. Connectors reach target systems to retrieve, verify, rotate, or reconcile credentials. Every request, decision, change, and failure is logged, creating evidence for monitoring, compliance, and incident investigation. Securing the vault itself requires more than turning on database encryption. Privileged credentials need protection at every stage, encrypted at rest and protected in transit with strong protocols like TLS. The encryption keys also need isolation and tight governance, often through an HSM, a key management service, or secure platform storage. The surrounding infrastructure matters too. Hardened systems, segmented access, tamper-resistant logs, and encrypted backups reduce the blast radius if something fails. Treat the vault as critical infrastructure. Patch it, monitor it, test recovery, and govern access continuously. A PAM vault also needs internal structure. Safes folders or partitions group credentials by business function, platform, environment, risk, and owner. That structure determines who can request access, who approves it, and who is accountable when auditors ask questions. A database team should not automatically see network device credentials. A development administrator should not inherit production rights. Good segmentation keeps access aligned to real responsibilities. Poor design creates shared ownership, over-permissioning, and messy reviews. The goal is simple. Every credential has a clear home, a clear owner, and a clear boundary. Access to privileged passwords should never rely on trust alone. RBAC turns access into a defined permission model. Requesters can ask, approvers can authorize, safe owners and administrators manage, auditors review, and emergency users operate under special controls. The key is separation of duties. No single person should be able to request, approve, use, rotate, and audit the same credential without oversight. For high-risk accounts, dual control adds a second checkpoint. A requester initiates access, an approver validates the business need, and the vault grants time-bound access with a full audit trail. Credential vaulting starts with discovery. First, identify every privileged account that could create risk. Domain admins, local admins, Linux root, database administrators, network devices, and service accounts. Then classify each credential by power, system criticality, shared use, and regulatory impact. Onboarding is where control becomes real. Import the account, assign an owner, set rotation rules, test connectivity, and enable auditing. The highest risk credentials get stronger enforcement, such as approvals, short access windows, session recording, and rotation immediately after use. Credential checkout turns privileged access into a controlled, temporary transaction. A user requests a specific credential, usually with a target system, reason, and duration. The policy engine checks whether the user is allowed, whether conditions are met, whether approval is required, and how long access may last. If the request passes, PAM grants access in a controlled way: reveal, copy, brokered connection, or launched session. Just as important, the full chain is recorded: tying requester, approver, system, time, reason, and credential to a complete audit trail. Think of checkout as a controlled access window, not a permanent entitlement. The approval path should match the risk: automatic for low-risk access, manager or system owner approval for accountability, ticket-based approval for change control, or risk-based approval when context matters. Once approved, access has a clear start and expiration time. The user checks out the credential, performs the work, and checks it back in to confirm the session is over. Rotation then closes the loop by changing the password, logging the activity, and preventing reuse. Password rotation shrinks the window in which a credential is useful to an attacker. Scheduled rotation changes passwords on a predictable policy, such as daily, weekly, or monthly. Post-use rotation is tighter. Once a user checks out a credential or completes a privileged session, the password is changed immediately. Emergency rotation is the rapid response option after compromise, termination, vendor offboarding, or an active incident. Reconciliation handles drift when the vault's password no longer matches the target system. Together, these patterns make rotation consistent, enforceable, and auditable. Rotation policy should not be one size fits all. Start by evaluating the credential's likelihood of exposure, operational impact, account type, and the criticality of the system it protects. A highly privileged shared account in production may need rotation every 30 days or even after each use. A low-risk user or service credential may safely rotate less often if monitoring and access limits are strong. The policy also needs governance, complexity rules, verification, reconciliation, failure handling, and notifications. The goal is practical security: reduce credential risk without creating unnecessary outages. Service accounts need special care because they are rarely isolated. A single credential may be embedded in Windows services, Linux daemons, databases, APIs, scheduled jobs, pipelines, and monitoring tools. Before rotation, the key question is, where is this password actually used? Dependency mapping answers that by tracing every consumer and downstream system. Rotation is then tested end-to-end, not just changed in the vault. Application owners must confirm propagation, restart requirements, and rollback steps. Without that coordination, a good security control can become an outage, causing authentication failures, failed jobs, and business disruption. A mature vaulting program assumes something will fail. If a service account rotation breaks during a suspected compromise, the first job is detection and containment. Alert, pause, unsafe access, and notify the credential owner. Then the team retries or reconciles the account state, rotates rapidly, validates the application, and preserves evidence. Exceptions are not informal workarounds. They need an owner, an expiry date, risk approval, and review. Break glass credentials follow the same discipline: vaulted, restricted, monitored, and tested before a real emergency. The core message is simple: protect privileged credentials first, then build stronger controls around their use. Vaulting provides encrypted, segmented, auditable storage. Checkout makes access temporary, approved, controlled, and logged. Rotation reduces standing risk, but it must be planned around reliability and dependencies. Next, we shift from controlling credentials to monitoring and managing privileged sessions.